first session on ISGs, which is a very interesting topic to do with a set of guides that the NSA has published in the US about how to sanitize files. And actually it's called ISGs, is Inspection and Sanitization Guidance, sorry. And we'll go through it, what it is. So first of all, just a quick welcome, just to say that, you know, we're here to participate. You know, we want everybody to just kind of like challenge and be solution focused. Everything we do is open. In fact, this is a great example of a project that we kind of trying to take openness and sharing and releasing everything we do in the Creative Commons and open source licenses. So actually all the materials that we create here is going to be released under Creative Commons, except, you know, the NSA documents are already published, but, you know, so they're not part of it. And also, again, with all respect, you know, we're here to collaborate. So, you know, let's all be very professional about what we do. And finally, here's the hashtag and Slack if you're not in there. And fundamentally, what we want you is to learn, and in this case, to collaborate. So moving on. So what's ISGs and how to convert them into checklists? So that's kind of the topic for today. And I want everybody to really be kind of collaborative. And this is a discussion. And there's definitely a kind of a heavy sort of, you know, presence here from Glasswall, which kind of makes sense because, you know, I work at Glasswall, and also this is a topic that we care a lot about. And some of these conversations is something that we were already talking internally, but now we want to bring this to the wider community. And fundamentally, ISGs are these sort of documents published by the NSA for a different type of file types. And they go into very good set of details of how, you know what you do with files, right? So they got these publications, which I'll walk you now through it, and they are very nice detailed documents that explain things. So if you go into these cyber security publications, there's tons of stuff in here. If you search for you know, inspection and sanitization guides, you get to see there's a pile of them, right? So a good example, let's say the PNG. If you then get the file, what you get is a nice, you know, detailed document that talks about the PNG structure. So this talks about, you know, how it's structured, the history, and how the actual PNG specification sort of works. And what's really cool about this is that it's not, you know, in a way, a super detailed guidance on every single thing about how to build a PNG parser. You still have the official documentation for that, but it's one that is very focused on the malicious use, in this case, of PNGs. So it's focused on the malicious use of images and is used through file formats and so exploitations of the files, and then it's through places that you can hide in the PNG that, you know, shouldn't be there, right? Some of these, you know, PNG is a good example of, there's lots of areas that it's very loose and allows all sorts of data to be inserted and allows all sorts of things to occur, which from a security point of view, we don't want to, right? We want an image to be an image. We don't want the image to be, you know, a zip or have all sorts of other payloads, which actually have, you know, in the past been shown to deliver some spectacular exploits. So the structure of the PNGs kind of tends to follow, especially the most recent documents. This kind of, it starts with introduction, what it is, the kind of background of the file, and then the kind of the structure of this document tends to follow this idea that, you know, defines the scope, then talks about literally the section 3 is you know, the structure of PNG, and then the section 4 is really what we're looking for, because this contains very detailed sets of risks and then the actions that we should be taking to protect the file. So fundamentally, the objective here is to create safe files, right? The objective here is to be in a situation where, you know, when there are an exploit for a particular file, we are able to protect it, right? You know, I can open a file, PNG, safely without having to worry about being exploited, right? And there's some cool examples, right, down here where of vulnerabilities and situations where, you know, a particular exploit has actually caused what's it called, you know, all sorts of vulnerabilities being triggered in what's it called, in you know, in parsers. Actually, the one that I actually had some cool examples is actually the EXIF one, this one here. This one had some really cool examples of vulnerabilities that that were actually triggered through this. So let me just quickly find it, and that's fundamentally what we're trying to prevent here. Right? We're trying to prevent here is cases like this, right? So if you go to these files, you see that this is an example of hackers hiding malicious codes in XIF data files. So this is an example of, you know, this actually was a really cool exploit in PHP, because basically what happened was they were able to create an image that actually on the extended, you know, information filter, whatever that thing is, the part of the file, they're actually able to put, in fact, you can see here on the camera model, it was actually able to put eval base64 decode JavaScript. So this was then triggered, and this was actually executed by PHP like this. So when you actually one of the readers that executed this, when you actually execute this stuff, this will actually trigger that particular base64 encoded JavaScript, which actually was running, if I'm not wrong, on a server side, which is basically what you don't want, right? Because you now have remote code execution on the other side. And then there's other cases of, for example, vulnerabilities in base, like for example, this one, you know, this denial of service, that's remote code execution. So this is really nasty, right? So this is basically a code overflow and basically code execution that arbitrary code by processing a crafted image, right? So that means that in this kind of vulnerability, you just by opening up the image with a parser that is vulnerable to this particular buffer overflow, you get remote code execution. So what we want is to make sure that we clean the file before it gets there. We want to sanitize the file, removing all this stuff before we kind of got there. And you sort of can see this in action with our engine. So we, you know, Glasswall has an engine which you can try with file drop or the forensic workbench. They're two different versions. This one basically gives you the, well, I have to need to drag and drop a file here. It gives you a version where, you know, you can, what's it called, just when you're on Azure, where this one, let me actually write this one here, where you basically, let me show an example of kind of the kind of things that you don't want to see in a file. So this is actually a PDF that has some JavaScript and some embedded files. And what we want to do here, so this will be on a PDF kind of format, is that, you know, we could see that, you know, it basically has, this is the result of the analysis. So we could see that it had JavaScript embedded, it had metadata, which is the kind of things we want to reduce. But also you could see that, you know, our engine actually picked up that there are a lot of things that we have to remove that shouldn't be there, right? So in fact, this particular case, there's actually an embedded file on it, which could be a virus, could be stuff. So we actually remove that. But the logic is all of these should be pointing to an ISG. And that's, again, that's kind of also our interest in this, which is that we want to, you know, make sure that every time we do something to a file, we can point to an ISG and we can have a set of very specific use cases for actually how it works. So to kickstart this process, they basically downloaded everything from that was available on the NSA website, because it's actually a pain to get. And actually there's some interesting race conditions with it anyway. But, you know, the point is to make sure that we got, you know, all the information available. And there's an interesting question on some of these file formats. Some of them might need updating, but this is also, as a community, we should be collaborating. So each of these folders contains the ISG for that file as published by, you know, the NSA, right? Which is basically all those documents I was showing you, which are really, really cool documents, really well written. So for example, on the PNG, you got the file here. And just to give you the full loop, what I was trying to do, and this is what I need help, right, is to create these PDF, so markdown files, which is basically, you know, literally markdown, right? So you could see that it's just basically nice markdown code. And then the logic is start to extract those things, for example, like data attack and the stuff to do the chunk format, stuff like data hiding, validate, remove, reject, right? And then the logic is to take this and then maybe create something like a JSON file that now has the source, what it is, and kind of those recommendations in now a consumable kind of format where we can now create specific keys so that when we look at writing tests for this and writing specific set of use cases, we can reference and say, look, the reason why we're validating this is because we following the 4.1 PNG 4.11 validation sequence, or the reason why this file got rejected is because it actually didn't confirm to this. So that's kind of the sort of loop, which is to create a set of industry sort of standard files that we can all collaborate and agree. And then so even from a tools point of view, we can measure which tools work well, even open source tools, right? We should be running open source tools through this, and validation tools, etc. But also that gives us a really good benchmark, but also a really good set of test cases to make sure that the tools are doing what they're supposed to be doing, but also that we can focus on the places where we know from a security point of view, we get the most value from actually providing that guidance. And with that, I open up to the crowd, like any comments, ideas, what do you, first of all, what do you think of this and these guides, and what should be the next steps?
I have a question, Dinis.
Yep.
This JSON that you've pulled out of the NSA document, obviously it's a reputable place. In core, when we've been looking at some of these chunks like this header thing, we've been looking at the PNG specification and work conforming to that. Obviously, it must be okay for us to be pulling out stuff out of this NSA document and creating these JSON files like this without having to cross-reference into the spec. I mean, it must. I can only assume that what we're pulling out, like what you've done here, is basically absolutely correct.
Well, I mean, correct in terms we can do it, or correct in terms
correct in what they say that, for example, actually the first 8 bytes are equivalent to blah 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 blah, the PNG signature. So well, we don't need to go cross-referencing into specs as well when we're generating these JSON files, do we?
Well, actually, that's a really good point, right? In fact, I think what you just raised here is that we should also have here, right?
A link to the spec?
Yes, absolutely, right? Yeah. So you should actually have here almost like a reference, right? Which is, for example, where in the spec, right? This is said, this is mentioned, right?
Yeah, so, that's a lot better, I think.
Yeah, and then so look, some of this, yeah.
I think it's actually very good to cross-reference the specification, because I think, as you said, Dinis, quite some of these documents are actually from on the ESA site are quite old.
Yep.
Just to make sure that actually what the advice they actually got there and what they're looking for is actually still the right thing.
Yeah. But I think that's where we add value, right? So I get the feeling when I was reading these documents, right? Like even if you read the introduction, right? This is basically, actually, a really good thing that the NSA and the National Center of Cybersecurity, right, has done in the US, which is trying to move the needle forward in the kind of the defense mechanism, right? And a lot of these, right, there you go. Like if you look at it, the intended audience of this document is system designers, software developers and testers who work on file inspection, sanitization applications, right? It's like, that's the audience, right? And I believe that what they want with this is for the community, the industry to come together and basically work on this, right? So this is a good example of there's a lot of work that was done on this document, but it doesn't scale if you need kind of this higher authority to be publishing it. You probably need one source of truth, which eventually can validate some of these. But, from a community point of view, you want to actually get that cross-reference because, and as we know, right, you might even have to go into details to say, well, the spec says that, but we actually know that 10 tools don't respect that. Right?
So is that what we're trying to achieve with this ISG, with this JSON stuff that you're showing us? We're trying to create a reputable single source of truth.
Yes.
And obviously branch out to wherever, like the references to the spec.
Yeah, correct. I would love to get the people that work on a PNG standards to validate this, right? We should be able to, especially when you get to PDF and Office and some of the more complex files, right? We want those experts to validate our assumptions, right? We want to start to agree, right, on specific parts, so we can basically work together on this. Does that make sense?
Absolutely. Yep, it does.
And the work that you guys done, right, on understand the spec. So I expect, for example, from our side, to have cases where this actually is harder than what we do, and then we go, actually maybe we need to update our rules. We might find cases where this is wrong, right, because this is done without a lot of tools behind it. So I expect some of the stuff here might have missed. It's very easy to miss a character here, or to have guidance that in real world, maybe you thought it was benign, but now we know its problems. And you have cases where the spec actually says, something very different, or the spec is more evolved than this, and we need to contribute, or the community needs to contribute to these specs, right?
This might be an obvious answer, but this JSON, you said end users will consume it. How will they consume it, and how will they make use of it?
Well, the end users in this is us, right? The end users is tool developers, right? The end users is or clients, or anybody who needs to validate, right, that a file is correct.
Right.
Right. So basically, this is test frameworks. Sorry,
yeah,
go on, Brent.
The kind of way I look at it for Vin is kind of from an ideal perspective, from my point of view, from the testing side, is there's enough information here to create your test, create the data, and execute the test.
Okay.
And that to me is kind of would be really fantastic, because effectively what you're doing, you're taking the document, you're creating it into something like that, and then effectively the rest of it becomes, hopefully an automated process of of actually testing through this, or creating some tests to actually validate that our software is doing what it's supposed to be doing.
Okay, understand.
And look, this is where, from a security point of view, right? And I have some experience writing fuzzers and exploiting files, where I was doing blindly, right? I was literally, I found a bunch of 0 days and vulnerabilities literally by, taking a binary of a file, XORing it, kind of, byte by byte, running through a debugger and seeing which ones popped, right? It's like literally, leave it, go for dinner, come back, and you have a bunch of 0 days, right? The engines are a bit better now, but that was basically, me going blindly and saying, hey, you think you have, 20 files here, you actually have 100. You think you have 15 blocks here, you actually have 5. But by the way, modify all the file sizes. So the logic of this is that, like, for example, like when we come here and say we took away metadata, or, we basically took this guy out, right? So there was document contain this, let's say this XML metadata and document catalog, right? There has to be a rule here, right? In the PDF spec that says that, right? It's literally, it is that simple, right? So this actually explains the catalog, and then down here talks about, there you go, right? So if you look at that, it says, hey, replace trailer with a value in, etc. So everything we do should be provided, should be mapped to one of these, and it's either, it's almost binary, right? It either exists or it doesn't, right? If it exists, we do the connection. If it doesn't, it means that we need to augment this spec.
I think the other thing, probably the trick we've kind of missed with not really using these guys enough in the future, is actually some of the design decisions that we've kind of gone through. I just think about recently we were arguing about internally about what we should do with the truncated EOF in a PDF. Now, I haven't gone through this guide yet to find out that recommendation, but think we should have just, if we'd have known about it, we'd have just gone here and says, okay, what does this guide say? And it just might give us a clear steer.
Yeah. You know, and that's exactly the idea, right? The idea of this is to have very rational reasons why we do something.
Yeah, I think we have been in situations before where we're a bit unsure what we're supposed to do at some bits.
Yeah. But you see, like, you know, and I think we as an industry should be basically be having this conversation in public, right? You know, like this is one of those things where you know, when we look at, you know, how we make those decisions, that should be a very clear reason why we will block a file or we don't, right? And I think as we move forward, I really like this idea of the detail that you got here, that we should be providing, you know, visible ways to explain what we do, right? So if you look at from a test case point of view, so the PNG is a good example, right? So the PNG has some really cool case studies here, like say that one, right? So here's an example where he says the chunk order has this, you should start with, the first one is the I header, right? So that's the definition of the thing. The problem is that you can actually, you know, put a bunch of stuff before it, right? So you can see, right? There you go. This data is not seen by users because there's the I header. So here's an example where we need a file that has this, right? And we need then actually probably the file on the other side, or we need a way to validate that these particular bytes are actually set in this particular way. And then we need to have basically a test case. So what you're looking really here is a test framework.
Hi, Dennis.
Yep.
Elvin here.
Yep.
So in the past, we've built a tool which actually basically our engine's integrated into it, but it allows us to actually search through the binary contents of a file as you process it. So for example, you could supply it with an input file, and then in a configuration file, you could say that I expect to detect this particular sequence of bytes in that file after it's processed or before it's processed. And then that then gives you a passed or failed status depending on the conditions you've actually set in that in the configuration file itself. Is that something along the lines of what you were thinking in terms of verifying this content?
Yeah, and we should open source that tool.
Cool. That's not a problem.
But that's a perfect example, right? Like, and this is already a good situation. Like, so if you look at this, right, this thing here says, oh, before the IHRDR, you should have this stuff. So you now have a tool that is able to open up the file and expose this. You know, it's kind of like, you know, that thing that we published a while back with the ability to almost start to create mini DSLs for this, mini cameras, right? So you could basically have a mini sort of version of that just focus on these specific use cases, right? But the problem is at the moment, and this is quite nicely the way he describes it, the problem is when you look at this text here, see that test, validate there's no data before that. What does that mean, right? So in a way, what we need to do is expand this. You know, imagine even a more evolved situation where you almost have a BDD language for this, right? When, you know, on the header before this, you expect to see this, or I don't expect to see that, right? So what we need now is to translate this into test cases. And those test cases should be written, you know, in Python, nodes, whatever language somebody wants to do. But what you want is to have, you know, use case in, use case out, right? So we want file in, file out. So you get file in with a specific set of requirements. So we might end up creating, you know, one file that has 10, 20 of these particular things so that, you know, we get to reuse it. But with every test, we are looking for a very specific signature.
Cool.
Yeah, go on. Now go on, Elvin.
Oh, no. I was just saying cool.
Yeah. Now, I think also, Dennis, potentially some of these things is because I think it does mention that usually most of these ISGs do kind of reference it, you know, like read in conjunction with some other documents, whether it's the specification or a data transformation guide. So quite often I suspect that sometimes where you've got that text, that there is no data before the I header, it's from those other documents, you kind of be able to work out what that was. But I agree, you kind of needs to be a bit more explicit in some cases.
And there's probably cases here where we have to disagree, right? There's probably cases here where it says, well, that's it's all nice and good, you're saying that, but that's actually not doable. Or we might have cases where we know, look, this will break, you know, X apps, right? You know, you might have a situation where it says, look, if we do that, then, you know, that printer won't be able to read it. Or, you know, we know that, you know, there's a number of applications that actually abuse that. So, you know, the way I look at it is that allow us to start to go into that granularity of understanding, you know, that this is actually almost a threshold where we can be super strict or we can be a little less strict, and it depends where you want the things to go to, right? But I think the really interesting part is when we're looking at the things that protect these vulnerabilities. So for example, one of the things I would like to know is when you look at, let's say, this execution of buffer, you know, this basic situation, this integer overflow, right? Where is this actually in the code, right? So this literally should be addressed by one of these requirements, right? And if it's not, it's a blind spot, right? Literally, you know, so when you look at this is an integer overflow in that library, which basically means that you put a specific tag, most likely, you know, with one of the tags that determines how many blocks you've got, and that then overflows the engine, and then you get remote execution because you put the shell code in the image and you basically pop the engine. So that's kind of the things that we also need to map and identify, which is what are the type of vulnerabilities that each ISG is actually protecting. And these actually scales much nicely, because if you look at, you know, a lot of the parsers, a lot of these parsers are written in C or C++. Some of them might be a bit older, but even some of the new ones, right? Sometimes it's very easy to make mistakes, right? And to have basically a buffer overflow on these engines. So if you can make sure that the files that arrive at those engines are already really, really clean, in fact, it might actually improve dramatically the performance of those engines. Any other comments?
Notice when you started the session, you went through sort of the conversion to Markdown in JSON. Did you actually get to a point where you were able to convert that to JSON, or is that just an idea of where you'd like it to end up, with an example of where you'd like it to end up? And how did you go about converting it, if that is the case?
And I was literally doing that before the session started. Yeah, look, this is a good example. Like we need to experiment, right? Like this I would say, you know, we need to create 3, 4, 5 versions of this, right? We need to evolve. You know, we need to take this all the way to writing tests to understand.
Was this manually created? Sorry.
Oh yeah, this was manually created. Yeah.
Okay.
Yeah, I don't think that some of these you could create it, you know, programmatically. I think you can, you know, we can, you know, import a little bit, but it's one of those where, you know, maybe as we move downstream, right? I think what will happen is we need to pick a couple of these that we're quite happy, right? To basically do a first run. And PNG might be a good one, but I would like to hear your opinion on this, right? So we need to pick one of these that is not too simple, but not too complex, that allows us to do this end to end, kind of probably a bit manually in the beginning. So look, this is just me parsing the file, right? This is just me. In fact, you can see here that I haven't converted the rest, right? So you literally go to the PDF, you copy and paste it, and then you add this information, right? And ideally, this should eventually be links, right? This should be links to each of the tests.
Could you open up one of the ISGs, the PNG ISG, for example?
Yeah, yeah.
I'm just curious. And could you go down to the section where you've got all those sort of verification steps, or essentially what each one of those breakdowns below?
Oh, it's this one.
No, it's further down, I think.
I'll find it. Well, you mean like this, for example, this bit here?
No, where it actually maps a particular sort of vulnerability with one of those recommendations.
Oh, I haven't seen that. I don't think they've done that very well.
Okay.
Yeah, no, that's one of the things I think we need to do, right? Because when I was reading them, right, I didn't find a lot of cases where they basically said.
I think they do it in a few places in some of the bigger file formats.
Yeah,
Maybe
probably
not
do. Yeah.
not PNG.
Yeah, but again, like we need to find them and then use that as a format. So for example, on this one here, it's included in some of these references here, right? So when they mentioning, for example, there, and they say, yeah, see, look, so here, when they mentioning, look, see, the vast majority of the exploits have taken advantage of either poor input validation or errors in commonly used, XIF parsing libraries. And there's the link, and there's that, vulnerability list, right?
Mm-hmm.
But I think it would be really good to find a couple of ones that actually have that really sort of good example, and that's something that I think a number of the people that call, like we should be collaborating on this, right? This is a piece of work that it's literally like project management. Let's delegate the tasks. Let's break down. Each person takes one file or one bit, right? And then we kind of figure out how it works, right? But at the moment we're starting with the PNG, like the PDF, like the only thing we've got is a PDF. So everything else is up for us to work and define and collaborate. And I'm very curious that once we can reach the security community, there's a lot of security research out there that have been trying, finding vulnerabilities and finding these things. And actually, when we can reach out to the developers of these libraries, they should be able to provide a lot of information. They should be able to provide, in fact, a lot of test cases, a lot of test files, and examples of problems they had in the past, and basically files that pop their engine that doesn't anymore, that we can basically to go back and almost reverse engineer, that is, why is that popping that engine, and what on the specification is preventing that from occurring. In fact, a really cool test would be to have the engine in a way that we can actually control which of these requirements we actually run. Because if you think about it, even from our, the rules base, each of these should be mapped to a specific rule, right? Inside the engine. So, and that should be configurable, right? That's like our policy on steroids, right? But this is, like from a security angle, right? Like my view on this is that you have to always, every time you provide a security guidance, right, you have to have evidence, right? Like I'm always very allergic to any kind of security guidance that doesn't come around with very strong guidance for why do you do that, and what's the side effects, and what you're trying to protect, and that literally is just a graph, right? So if you visualize this, it's just a gigantic graph that can start as JSON files, right? Start in this kind of format, but then we'll put it in different ways, right? But this is a graph, right? If you think about it, nodes and edges, right? That is just one of the nodes that then connects to other nodes and and other edges.
I'm actually thinking in terms of sort of extracting information from the PDF files, right? And some of these are quite large. Would it not be sort of worth having something that can translate a PDF into a different format and then searching for those sort of recommendation sections? Is that not all the information you actually need from this? That's essentially the checklist, isn't it?
Yeah, I think the problem you have, and this is a good example, right? The problem you have is that these documents are not normalized, right? So there's an argument to be said that we should be able to recreate these documents from here, right? In a way, the way when we explore with the idea of creating the Jira tickets, right, to store the data, right?
Yep. So
the problem you have here, I'll give you an example, right? So if you look at this, you're going, oh, okay, this is pretty cool, right? So there you go, a PNG, there's the overview, there's the risks and validation. Like that is super clean, right? Look,
yep.
You've got an introduction, right? You got the data attack, and you'll see that this kind of, it goes in multiple bits, right? So sometimes they have, look, see, so this one, like you got data hiding, data attack, right? And he gives you the recommendations, right? What you do, which one of these, and in fact, you know, even this one, I will argue that you should split, right? This and that, right? Like, so even this is not normalized. Like, okay, so when I'm doing this, am I addressing with data hiding or I'm addressing a data attack, right? So, you know, it's kind of like, okay, so this is why. Is this for validation or is this for things? So even this is not very well normalized. But if you look above, this guy doesn't have a good introduction. Look at the introduction. It's like literally, that's the introduction, right? So in this case, we don't want to put all of these, right, in, what's it called? All of that. We don't want to put all of that in a JSON file.
Yeah, but the sort of the bullet points, are actually all covered under, is it risks and recommendations, is it not?
Yes. So yeah, what we could do is extract all the risks and recommendations in one go. Yeah.
Yep.
Yeah, that you can. And but this is one of those where sometimes, you know, it might be easier. Yeah, we could try to do it all programmatically, right? Yeah, and see how it goes, right? I was literally just copying and pasting this, right, and then cleaning up the markdown, which also works quite well. And sometimes actually doing this manually actually allows you to already think a little bit about it. And
so I think at least an initial extraction can probably be done programmatically, and then you could go over it and verify, because we've played around with, obviously we have to go through quite large specifications. They're all in PDF format as well. And in the past, we've actually created tools to extract information and create templates from PDF files. So cool. I think it's possible.
Yeah.
At least to speed up the process anyway.
Yeah, that sounds real good. These documents from the NSA, how often do they change? And what I'm thinking is, with some of the other ones, say for example, do you get a format specification that changes quite often? And do we need to keep referring or rerunning the tools to extract the information back out and refresh our ISG?
I think that this, in the last sort of, as far as I'm aware, in the last sort of 4 or 5 years, this has changed twice.
Okay, not that often then.
No.
But that's actually a problem, right? Because, and I believe the reason why it doesn't change very often is because I don't think the industry...
It's not utilized enough.
Not utilizing it. Because the reality is this document should be changing regularly, right? Yep. Because this document at the moment is a piece of art, right? Like, you know, to update this is probably a pain. Like this, it probably, you know, think about, you know, it's probably faster for us to ship software than to update this document at the moment, right? Mm-hmm. But you want a situation where this document can be refreshed, you know, quickly based on feedback, based on, you know, adaptability, kind of new data that emerges or improvements.
So ultimately, our ISG becomes the single source of truth, and then we tend to just retrospectively look at this, make sure nothing's changed.
Well, I think we should submit, right? I think you want something like the NSA or, you know, or the national, you know, the UK, the National Cybersecurity Agency, right? They should be publishing these documents, right? Or another body, right? That they should be publishing. You know, the in the US you got the let's see, what is the other one? The one that pushes a lot of standards, right? That, you know, they should be providing, you know, that sort of truth, right? You know.
So fact, essentially we become a contributor.
Yeah, absolutely, right?
Yeah.
I mean, one of the little things I actually did today, just kind of more as an academic exercise, but it was quite revealing, is I actually took the PDF ISG and ran it through our engine. Yeah. And it actually threw out quite a large number of remediations. And I was just thinking, but you kind of get the question that says, actually, are these things that actually should be covered by the document, or, you know, are they just additional things that we're actually doing? You know, are there actually vulnerabilities associated with all those things that our engine picked out?
That's actually a good example, right? Is the ISG of the PDF compliant with the ISG of the PDF?
Yeah. Well, as I say, if you do it, Dinis, if you drop it into the file drop, you know, there's like 27 remediations.
There you go. Well, that's our recommendation for them, right?
Yeah, to bear in mind, Glasswell is super paranoid.
Well, that's how it should be, right? But I think it would be interesting to point out where, right? It would be interesting to point out, like, and in fact, like that would be a great test case, right? So if I take this guy here, which is the PDF, actually, Elvin, I was going to show you this. Can you see that on this one, the recommendations are all over the place?
Yeah,
they're not on the section 3. Well, actually, it happened to be on section 4, but there's actually recommendations on section 3, section 5. I think it's because an older document that did that. So, but you're right. I think if you can extract that, right, and then we can use some of the team members to just start going through it. But I feel that we probably can want to focus on 1 or 2 documents, right, and then really get the end-to-end set of files, examples, automation, how the whole thing works, right, through it, so that we actually get a feel for everything. And then when we go to the other file formats, I think it will be easier because we already got the multiple bits in place.
Mm-hmm.
Does that make sense?
Yep. Which
is kind of what I think when you guys mentioned before, right? Like, if the first couple is going to be the harder ones, right? There you go. Look at that. That's funny. So look, the reality is, right, that this should be pointing, right, to an entry. Where is it? On the PDF, right?
It's interesting. I noticed on that what you just run at the bottom, there's an app segment removed. If you go back to if you go scroll down, there's an app segment.
That's some metadata from an image embedded within the PDF.
Yeah.
Is that associated with JPEG apps?
I believe so, yes.
Where's that one? Which one?
Fourth from the bottom.
Oh, APP segment remove.
Because what you was talking about, the EXIFs, and I think EXIFs are in the JPEG camera in app 1 segment.
Yeah. Yeah, there you go, right? All the stuff, right? So in this case, metadata removed from original. So it's actually interesting to see what we actually removed, right? But so the logic here, right, is that you now want to point. So if I go into this and I look for that XREF, right, recommendation that these guys might have, right, there has to be one of these. Look, replace, right? So, for example, right, is this what we did? Right. So if you look here and you look at that reference that we've got, for the XREF, entry offset exceeds the file size of the input file, even these texts, which I think, we created, out of what we understand, should be matched here, right? That text should be literally, should be referenced here, right?
Mm-hmm.
Because, when we say object exceeds the file of the input file, entry offset, I would expect to have like if you think about it, when I click here, I should have access to something like this that then tells me why, tells me the reason, tells me even in the spec. So you can imagine that this JSON file is then what we will then reference here.
Mm-hmm. Cool. Yep. Quick question from the file drop. Are you able to download the sanitized version?
Yeah.
Could you then compare it to the original?
Yeah. Oh, from a diff.
Yeah. It's a text format. You might be able to quite clearly see sort of the differences.
Actually, I don't think I have a binary diff on this file. Yeah, I don't. Can one of you guys do that quickly? Just drop both. So you can get the file from here, right? So if you go to the ISG.
I would do it, but I'm actually going to be shooting off for about 10 minutes to pick my son up, and then I'll be back on the session.
Yeah, so you can, well, maybe that's a task we do tomorrow, right? But so we get that there, right? And so that'll be interesting to see the difference, right, between both files. And then, so this is now the file being processed. So actually that's interesting because we can actually process the files and put it, look, there you go, right? So we can actually put both files on the GitHub repo, one which doesn't have those things, right?
Yep.
And cool. Well, I guess there's just okay. Any more comments on this? So I think that the final just thing I was wanting to quickly talk about is to think about, you know, how do we make these checklists, right? So how do we actually create and visualize these sort of checklists so we can extract, you know, all, you know, what I want to see in one go is every one of these, you know, requirements. And have it in a way that you can say, here are all the validate ones, here are all the removal ones, here are all the reject ones. And basically, you know, start to think about how we create a checklist and then how we test for it. So any ideas on the best way to do that without creating a gigantic spreadsheet? Which is an option, right? Look, one option is to bring this into a spreadsheet, right?
Yeah. Having something, as I say, in a JSON or something like that, I think that's a bit more useful for something, because it becomes easier to programmatically sort of pick out something, you know, spin something else out of it.
Yeah.
I think one of the things that's quite interesting you've been going through about, I think the first thing is like actually what's the information that we actually want to pick out in the ISGs, kind of create that guidance. I mean, I think a lot of it is right. It's the validation rules about it. Then there's also think about, okay, what's the additional information that adds value to that? You know, what was it? You know, like references to the specifications. You know, and I think the other interest, you know, again, is like that. Okay, what are those exploits? So you know, it's definitely stopped this. You know, that would be really cool as well.
Yeah. But now we can start that, right? Now we can ask the question, if you know an exploit, if you have exploit files, you know, who has, for example, like do it like an open request for exploits, right? So if we take an exploit and then we kind of do, we can even use our you know, some of the other engines out there, right? And say, look, you know, here's an exploit, you know, what this exploit is actually, you know, what are we already removing from the exploits? And then, you know, reverse engineering that to say, well, this is actually being addressed by this, this, and this. And that's kind of the next steps, right? I think what we want to do this week is kind of to move the conversation forward so that, you know, we you know, hopefully we can get, it's easy to evolve the kind of next, you know, set of contributors. So it's like, it's open source project, right? We just keep starting it. All right, cool. Well, if you got, you know, any other comments or things, because I think that's basically the objectives for this session. You know, we don't have to go to 2 hours, right? I think this is good. I think we've moved the needle forward, right? You know, we kind of, you know, we got what's the ISGs, you know, how to convert them to checklists. You know, that's JSON file is a good example of that. And then we can continue tomorrow.
Cool. Very interesting.
And tomorrow is kind of, maybe it's, you know, so that's why, you know, I kind of try to create these topics where, you know, one way would be, you know, how to measure, you know, and we can kind of, you know, merge these two a little bit, but like how to measure and visualize the standards, right? Like, you know, I think one thing that we can think about is once you got that into a checklist, right? And maybe, you know, some of you guys can do a bit of thinking beforehand, is that, okay, then, you know, we need a way to start rating, right? The engines, we start rating, you know, how much, you know, if I have a 5 or 10 or 100 test files, I should be able to visualize it, you know, like, you know, what is each file doing according to the standard, right? Oh, so what is each engine doing according to those files? And then, you know, you can think about how to create test cases and to create, you know, these kind of, you know, workflows for it.
It's kind of an interesting one when it comes to creating the data, because I think you mentioned earlier about like having one file that's got multiple functions, but I kind of say I'd kind of like to keep it clean and knowing that I've got one particular issue with a particular file, and that's what I was going to pick out.
Yes, and that's what I think we need to do here, right? We need to pick 1 or 2 or 3 examples and then just do like the end-to-end piece of work on those guys.
I was thinking about the test data rather than the actual things. I mean, definitely, I think definitely is we need to pick 1 or 2 of these documents to kind of set it up.
Yeah.
Work out how best to organize stuff.
Yeah, and we can use the repo here to add files, right? So you can basically, if you go to here to the PNG file, we can add to this section test files, right? So maybe one of the things for tomorrow is let's add. So maybe you guys think about what will be for out of these ones. What should be the one that we start with, right? What's the ones that we can already do quite easily, and there's good data and we have good sets, right? So pick one, again, ideally probably not PDF because that's massively complicated, right?
I think PNG, I mean, one of the interesting things is, so something like some of the examples that are given in the PNG document, we can create those quite easily because we can just get a hex editor,
yeah,
add the text in that they actually show in the document, prove that we removed, so that's quite an easy one because it says here's what they've actually visually represented it. So that's something very easy for us to create.
Yeah.
There's also the possibility of stuff like binary Excel, which is record based. So a lot of the structure itself is pretty much repetitive. So the recommendations would probably also be along those lines or of a similar nature, I'd imagine. So that might also be something where you get quite good coverage across quite a big file format, but without too much complexity.
Yeah, correct. Yeah, and the way to scale this is with the graph, right? So if you think about it, as we hyperlink these things, right, that's how we will scale it. So, I expect that once we do a couple, the next batch will be easier because it's going to be a repeat of a lot of the same things, right? And the same technology that we use, for example, to validate that it works in one format is going to be the same one to validate on the other file format, right?
Yep.
Cool. All right. Any final comments for today?
If we've got ideas, etc., and say where do we share that? How do we communicate that?
Oh, on the repo. Yeah, on here.
Okay.
Yeah, I'll open an issue if you want. Yeah, send files, send a pull request. Right.
Do we have a dedicated Slack channel or anything like that?
Yeah. There's a dedicated Slack channel in the Open Security Summit.
Cool.
Yep, there's a link there, and I'll get you the link. Oh, I'm not actually on the thing, but yeah, there's a dedicated Slack channel for the ISGs. You need to join. So you could join if you guys not on the Slack channel. There's the link here at the top. That link there, has the invite. If I can show you here on the web. Yeah. So yeah, there you go. Right. See. So that ISG, and there you go. So that's where we've been talking about this.
Cool. Perfect.
Cool. All right, so let's call it a day. Let me stop the recording and